Today we're going to do a very quick session on how to debug C++ program in Linux. We have a very small source code here, and the purpose is not to analyze the source code or a complex one, but instead how to debug it. We have a make file. So we have two binaries that are generated from the source code. The first compilation instruction will generate it, will do a native build, and the second will do a cross-compile executable for an ARM64 architecture. And in each of these builds, we pass the -g command option to put a symbol table into the generated binary. Or just do the build by typing make, and we can see these two binaries generated. The first one would be a binary for an ARM64, and the second one would be a binary for Intel architecture. So we can only execute the one for Intel here since it matches our architecture. And if we try to execute the other one, and it will not execute because it's not matching the architecture. However, we can copy this to a remote target that has an ARM64, and this one will execute. But if we're doing that, it is first tackle how to debug this small program. So to debug this, my favorite way of debugging is the CGDB. It is just like GDB, but with a more nicer user interface. So I will type CGDB and I will specify x86 there, and we can see that it has a nice UI. I can put a breakpoint in line 5, and we can see, and then execute it, run, and then we can see a green arrow here saying that we are at this line now. And then if I type next, then it will execute that, and then type next again, then it just executed the cout, and the output of that is here 0. And then I will type next again, and then now it's about to execute the second cout, and it will print out the value of I. To know the value of I, you can just type pi, print I, then and see here that I is 1, and then if I type next, it will print the value of I, which is 1. And then continuing next, you can see the arrow is moving up, and then print the value of I again, and now I is 2. And if I execute the print statement, it will print 2 next, and then we can see that we exited the for loop and about to exit the main program, and there, and then the program is exited. So that is how to do it using CGDB. So the alternative of this would be just GDB, okay, there, and then you're gonna enter, but then there's no user interface to show you the source code, except you can type list and you can see the source code, and you can type break, and same commands are supported here, guys. Then type run, and this is how it looks like if you're using the main bare bones GDB. However, you can also say layout next, and it will show you the source code, okay? But then I think the graphics of this will break, like, let's see. Oh, it's not breaking. pi 2 and exit. Well, it looks after all. Anyway, that's how you do it. Either you do it either GDB or CGDB. But if you do GDB, be sure to type layout next in order to pop up that window that will show the source code. But how do we debug the other cross-compiled binary? First, let us try to copy this cross-compiled executable here. But first, let me log in into the ARM64 board. Okay, so I am indeed an ARM64 board here. And let me copy this one there. Copy it in the temp directory. Okay, sorry about that. So now it's in the temp directory, and because this matches the the system as CPU architecture, we can definitely run this here this time. And so it runs, executes. But how do we debug this? Well, you can just type GDB server, localhost, it should be localhost, and any port number greater than 1024, of course, 14344, and then main there. Press enter, and it will be waiting for a connection from a Linux machine here. So now that here we have to use the not GDB guys, but the GDB multi-arc. Okay, this is the one that we're gonna use to debug a remote ARM64 board. But if I want to continue to use my CGDB, which gives me a nice UI, I can continue to use it by typing CGDB. I will advise what the debugger to use, and then the name of the cross-compiled binary here. So we have a nice looking UI here. But then we're gonna specify the IP address of the ARM64 target. So we're gonna say target remote, and the IP is 136, and the port is 144. I'm gonna press enter here. The remote board which is listening now is gonna detect the incoming connection. See, detected an incoming connection, and then here we're gonna put a breakpoint, break 5, just as we did in local debugging. And instead of run, because run is not allowed here when doing remote debugging. In fact, if you type run, it says not allowed. Instead of run, the command here is continue. Enter. And see here that this green arrow is pointing to the current statement to be executed now. And you can also see here that it loaded the cross-compiled library dependency. Okay, so it pulls in some of the needed friends in order to run the cross-compiled binary. It's sort of standalone because it's just a basic pure C++ code with no dependency. In the event that there are dependency, then you have to map out those dependency locally in your Intel system. Either you do that with SSHFS, NFS, or you manually copy all those dependent cross-compiled ARM64 libraries. So now that we have a breakpoint, I can continue to debug this by typing next. And you can see the green arrow is moving to the next statement at line 6. It's about to print the value of I now. I can see the value of I by typing P and then I, and say I is 0 right now. If I click next or N, and the output is printed in the remote target 0. So now the arrow is going back to the for loop. I can continue to press N, or just by pressing enter, it will just default to the last command, which is N. I'll just press enter, and it will just be like that. So it printed 1 now, and it printed 2, and the value of I here is 2. Okay, so since it's less than 3, I click next, but here okay, it incremented I plus plus, so it definitely exited from the loop. So next, next, and then the program will exit, and you type quit, and then everything is the debugging is over. So that is it, guys. I mean, the main hardcore way of doing it would be like this, GDB, right? And it would be the same. Let's try that. Layout next, and then break 5. Oh, no, no. I'm gonna set target remote there. Wait, we first have to run the guy here, and then they're connected now. Then break 5, and then continue. Cont. The program is not being run. Wait. Okay. Well, the issue here is we are using GDB. Like I said, we have to use GDB multi-arc. And Okay, what I'm trying to show here is instead of using the Carses-based CGDB and specifying the GDB multi-arc as a debugger, this time I'm using it the core GDB debugger, the bare bones debugger. Okay, we run it now and target remote. Now it's connected and layout next, break 5, and then continue. Okay, so let me click next. So print the volume I think it's working fine after all. Well, sometimes the CGDB has some colors, but this one does not have color. So, well, in some cases, the text-based GUI here will break. So, I don't know. It depends. Well, that's it, guys. So, in summary, we use GDB, we use CGDB, and then we use GDB multi-arc, and then we use GDB server. So remember this, GDB, CGDB, GDB multi-arc, and the GDB server here in the remote target.